Hey everyone, look, it's a unit circle. So the unit circle turns out to be, and us knowing the unit circle, turns out to be that something that's as important as learning the multiplication tables was. No, really. And so you really need to know all the things on this unit circle. Um, to that end, I hope that Mr. Paws is going to hold up tradition, which is to give unit circle quizzes until everyone gets 100% on them. Yes, that means even if you have gotten the unit circle quiz and gotten those 4 points from the first time you took it, you're still taking it again, just like you had to keep taking that multiplication tables quiz over and over again until everyone could do that stuff. Yeah? So here's what I want to point out. I want to point out that we've got here this is 60 degrees, this is 30 degrees. And because it's the unit circle, we know that the radius is 1 unit. So this is 1. So do you remember your shortcuts for 30, 60, 90 triangle? There we go. That the short leg was half of the hypotenuse, and the long leg was the short leg times root 3. That's where that stuff is coming from. Now, where did those values come from? How did we know that this is twice this? Well, we could come over to the Pythagorean theorem and say, we know the equation of a circle, x squared plus y squared equals r squared. Yeah? And we know in the unit circle that radius always equals 1. So x squared plus y squared equals 1. Fabulous. That's our unit circle, center at the origin. And now I'm thinking about these unit circle values that we've got. And I notice that when I'm talking about this triangle, is 60 degrees. What can I know? I know this is 1. No, I don't know how to use that yet, but I will by the end of this video. So I think, yeah, right now the only way I have to know these other sides is to use the trig functions that we're going to talk about in a few minutes, or to use those shortcuts I've memorized. So since I don't have that trig stuff on hand, and we might not remember these shortcuts, I'm just going to say that, look, this little amount is 1/2, and that's the overness. That's the x value. So here, I'm going to have a 1/2. And this length, that's longer than 1/2. Okay? This long leg is going to be root 3 times that short leg. Root 3 over 2. So that's where the ordered pair is coming from. This is a 60-degree angle, and 60 degrees, how many radians is that? Well, let's multiply that by pi over 180, and I get pi over 3. Okay? So this is pi over 3 here. Pi over 3. Good. Okay. So what I'd really like to do now is go through this and think about these values. Because I noticed that there's that big triangle here. Well, this triangle is the same triangle as this one here. It's just sort of fallen over on its side. So now the long leg is 3 over 2, the short leg is 1/2, and this is either 30 degrees or pi over 6 radians. Okay, and we've got this ordered pair here, 3 over 2, 1/2. Now, sometimes students switch these. And one of the things that I'm told helps them remember is that 1/2 is much smaller than root 3 over 2. And so when I'm looking at this triangle, the short leg is 1/2, and the long leg is root 3 over 2. Or, in this triangle, the short leg is 1/2, and the long leg is root 3 over 2. Okay? Okay. So, we've also got, instead of the 30, 60, 90, we've also got this triangle. This is our 45, 45, 90. 45 degrees we know is the same as pi over 4 radians. And because it's a 45, 45, 90, we also know that this is an isosceles triangle, because if these angles are the same, then the sides across from them are the same. Okay, so let's figure that out. Like, we know the hypotenuse, and we know the legs, and we know the Pythagorean theorem. So x squared plus x squared equals 1 squared. 2x squared equals 1. X squared equals 1/2. So now I'm going to come and I'm going to take the square root of both sides. And when I take the square root of both sides, what am I supposed to remember? That plus or minus. So we get x equals plus and minus. And instead of writing square root of 1/2, I'm going to write square root of 1 over square root of 2. And I'm going to rationalize. And so now I have plus and minus root 2 over 2. And that's what x equals. And since the sides are the same, then both x and y are going to be that root 2 over 2. And so if I look again at my unit circle, here at pi over 4, I have root 2 over 2 and root 2 over 2. So that's where those values are coming. Okay? Next, let's talk about this. Well, let's start with degrees. So there's a pattern here. Remember we were talking about angle as an amount of rotation? When I see this much rotation, I see it again here. Ooh, these two put together make one of those. So that's 30 degrees, and that's 15, 15, 30. And again, this wedge here, that's 30 degrees. And here's 15, and 15, and 30. And I can just sort of keep doing that pattern all the way around. And that's sort of really nice and convenient. And here's what I want to do with that knowledge. Okay, so this is 30 degrees, and then 15 more, and then 15 more, and then 30 more, and 30 more, and 15 more, and 15 more, and 30 more, and 30 more, 15 more, 15 more, and 30 more brings me to 270 degrees. 30 more brings me to 300, 15, add another 15, and get back to 360. So this is either 0 degrees or 360 degrees. And that's how I'm going to figure out my degrees. 30, 15, 15, 30. 30, 15, 15, 30. That helps me find all of these. Yeah? So let's take a look now at radians. We looked at those in our first video of the unit. And what I want to do is something similar to that. Last thing I did with degrees, I want to take a look at an amount of rotation. So this is pi over 6. Well, I see here the same amount of rotation. So this could be 2 pi over 6, which reduces to pi over 3. And then I see another one of those here. So that's going to be 3 pi over 6's, right? 1 pi over 6, 2 pi over 6, 3 pi over 6. And that reduces to pi over 2. Here's another one. And so we were 1, 2, 3. This must be 4 pi over 6's. And that reduces to 2 pi over 3. And then we see this one. This is going to be pi over 6. And here's another one. So now I'm looking at 6 pi over 6, which is the same as pi. Now I have a 7th one down here. 7 pi over 6. And look, another. So 7 plus 1 is 8 pi over 6, which reduces to 4 pi over 3. And here's another one. This one is 9 pi over 6, or 3 pi over 2 when I reduce. And here I've got 10 pi over 6, which is the same as 5 pi over 3. Now I'm looking at 11 pi over 6. And then finally, this last wedge here brings me back to 12 pi over 6, or 2 pi. So I can count these to help me remember what they are. Ideally, I'd love you to know that that's 7 pi over 6 without having to count to 7 pi over 6. But, you know, that it's okay for the beginning. We'll be fine with you counting. But you do need to get off of this. I mean, don't expect to have this on our tests and quizzes. In fact, you're going to be tested about this, as well as all the ways that we use this. Now, I just went through and I counted pi over 6s. Well, this amount is a pi over 3. So when I see this amount, that's pi over 3. Well, guess what? I see that amount here. This and this, same. So this is 2 pi over 3s. And then I see another one of them here. So this is going to be 3 pi over 3s, or pi. And then here, I see another one. So this must be 4 pi over 3 down here. And look, a radiation symbol. 5 pi over 3 here. And finally, this brings me back to 6 pi over 3, which is 2 pi. I can just count them if I have a sense of how much rotation is involved in getting that. And finally, pi over 4s. So this amount is 1 pi over 4. And here we have that same amount of rotation. This is going to be 2 pi over 4, which reduces to pi over 2. And then I rotate that same amount again. It's an eighth of the way around. This is going to be 3 pi over 4. And I have another one. This is now 4 pi over 4, which is pi. Hey, that's exactly what I expect to be there. And then we've got this one. And this is 5 pi over 4. We've got this one, which is 6 pi over 4, and we know that reduces to 3 pi over 2. And I'm almost done, because I got this one that brings me to 7 pi over 4. And I go just a little bit further. This is the same wedge, 8 pi over 4. Well, we know that is 2 pi. Okay. So, you've got the degrees, you've got the radians. How about the ordered pairs? Well, we said that we could use our 30, 60, 90, and 45, 45, 90 to help us figure out that this was 1/2 root 3 over 2. This is root 2 over 2, comma, root 2 over 2, because the x's and y's are the same. And here we've got root 3 over 2, 1/2. Notice how this x value is longer than this y value. Root 3 over 2 is longer than 1 over root 2. And notice how over here, that's flipped. The short leg, the long leg. So our short leg is the x at 1/2, and the long leg, which is longer than the short leg, is root 3 over 2. Now, as far as, we've got those. As far as these, well, the y values at each of these points are the same. All that's changed is I've reflected this point over here, so my x values will be negative. I'm going to have negative 1/2, positive root 2 over 2. Here I'm going to have negative root 2 over 2, root 2 over 2. And this one here, remember, this is the long one for x, negative root 3 over 2, 1/2. We have a shorter upness, a shorter y value. So 1/2 is the y, and negative root 3 over 2 is the x. Now, in the third quadrant, both x's and y's are negative. So this is going to be negative root 3 over 2, negative 1/2. And this one is going to be negative root 2 over 2, negative root 2 over 2. And finally, this one is going to be negative 1/2, negative root 3 over 2. Notice in third quadrant, negative, negative. Okay, and then over here in fourth quadrant, well, either I can take this and flip it over here and make all the x's positive, or I can take this and flip it down here and change the sign on all the y's. Doesn't matter which I do, I just need to make sure that I have easy access to the correct values here. Positive 1/2, negative root 3 over 2. Positive root 2 over 2, negative root 2 over 2. And finally, this one is going to be root 3 over 2, negative 1/2. Great. So those are all our coordinates, except for this one is 1, 0. This one is 0, 1. This one is at pi, negative 1, 0. And down here at 3 pi over 2, 0, negative 1. Pi over 2, pi over 2, 0. Okay? Excellent. So, you need to know this thing. You need to be able to fill out a unit circle for us in 4 minutes. You need to be able to take a blank unit circle and put in all degrees, 1 point. Put in all the radians, 2nd point. Put in the x coordinates, 1 point. Put in all the correct y coordinates, 1 point. So, 4 things to find and 5 minutes to do it. Okay? You need to be able to fill this out in under 5 minutes. So, please, please, please memorize that, that unit circle. And in a few minutes, I'll show you how we're going to plan on doing this. Okay? All right. So, trig. So, you learned about some trig functions when you're in geometry. Maybe when you were maybe last year in Algebra 2, depending on who your teacher was. So I just want to go back to this moment. And talk about SOHCAHTOA. Now, SOHCAHTOA is the way that many students, not me, because I'm dyslexic and I could never spell this damn thing correctly, memorize their basic trig functions. We've actually got 3 of them here. There are 6 that we need to know. So this is sine is opposite over hypotenuse. Okay? And so we're going to say that sine of x, sine of theta, there we go, is opposite over hypotenuse. Now, let's keep that in mind. That's the piece of information that we should already know. But now let's look at the sign in this picture. This is from our unit circle. We know because the hypotenuse is 1. What would the sine of theta be? Opposite is y, and adjacent, no, not opposite over adjacent, hypotenuse. So 1. Now, what do we have here? When we're looking for the sine of theta, that's the same as the y value on the unit circle. So if I want to know the sine of pi over 3, I'm really asking, what's the y value at pi over 3? I need to be able to do it that fast. Yeah. So sine is opposite over hypotenuse, and on the unit circle, sine is the y value. Please remember that this is only on the unit circle. In situations where we're not on the unit circle, we'll be using this. This is only on the unit circle. But that's helpful. So that's sine. What's next? Ooh, cosine. Cosine is adjacent over hypotenuse. That A is for adjacent. That's not an A, that's an H. Okay, so in this picture, the hypotenuse is still 1, and the side adjacent, well, that's the hypotenuse because it's across from the right angle. This one is opposite, so this is the adjacent one. And so we have x. So notice cosine is going to be the x coordinate on the unit circle. So if I want to know the cosine of pi over 6, I want to know what the x value of pi over 6 is on the unit circle, and that's root 3 over 2. Okay? Right. Oh, and hey, do this. Don't do this. Don't say cos equals x. Cos is a type of lettuce. Sin? No. It's a sin to write sin. Tan is something that we get from the sun and maybe we should get less of because we don't want to have skin cancer. Tangent of theta, though. No, don't. No. There's something missing in this. I need an angle. I need an angle. If you just write this, I'm marking wrong. This is a head of lettuce. A head of lettuce does not equal x. The cosine of an angle, sure, that could equal x. Okay, and what do we remember about tangent? Tangent is opposite over adjacent. Opposite over adjacent. Now, on our unit circle, opposite is the y, and adjacent is the x. So if someone says to me, hey, what's the tangent of pi over 4? I think, well, when I go to pi over 4, the y value is root 2 over 2, and the x value is root 2 over 2, and so tangent of pi over 4 is 1. So, yeah, I need to know my basic trig relationships, my basic trig functions. We said that sine theta was opposite over hypotenuse, and on the unit circle, the y value. We said that cosine theta is adjacent over hypotenuse, and therefore the x value on the unit circle. But again, these shortcuts only on the unit circle. These are the ones when we do like those triangle word problems, or even things that aren't on the unit circle. Okay? And then tangent theta. No, really, if you leave that angle off, I'm marking it wrong. Okay? And this is opposite over hypotenuse. So on the unit circle, the opposite over the hypotenuse looks like that. Now, I mentioned a few minutes ago that in addition to SOHCAHTOA, you also need the other 3. So, cosecant of theta is hypotenuse over opposite, and that's going to be 1 over y. And secant theta is hypotenuse over adjacent, which is 1 over x. And cotangent theta is That's not supposed to be hypotenuse. That's supposed to be opposite over adjacent. So this is adjacent over opposite, or x over y. Okay, so we need to understand on the unit circle as well as not on the unit circle. And remember, cosecant is just the reciprocal of sine. Sine theta is 1 over cosecant theta. Or I guess we could say cosecant theta is 1 over sine theta. So this is the reciprocal of that. Look, hypotenuse over opposite becomes opposite over hypotenuse. Adjacent over hypotenuse becomes hypotenuse over adjacent. All right, SOHCAHTOA. I could never spell SOHCAHTOA. No, really, I'm not kidding. Part of the reason why I failed math junior and senior year in high school was because I just couldn't get my head around this. Really. I mean, it was just so emblematic. No, couldn't spell it. So, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Or, some old horse caught another horse taking oats away. So, while I couldn't necessarily spell SOHCAHTOA, and having the teacher just repeat it, that did not help me know how to spell it. Maybe you want to come up with your own little mnemonic device to help you with this. Because when I learned some old horse caught another horse taking oats away, suddenly I was able to really remember these trig ratios, and things went much easier for me. Okay, so I want us to now sort of go in this new direction. And this new direction is, you need to be so good at these. Sine of pi over 6. Sine is the y value on the unit circle. And I'm looking for the y value at pi over 6. Okay? So that's probably the process that you're going to go through now. By the end of next week, before you take your unit assessment on Trig Basics, I would like you to be able to do cosine of pi over 6 is the x value at pi over 6, which is root 3 over 2. I mean, it should really be that fast. It should be 6 times 7 is 42 fast. Cosine x value at pi over 6. Oh yeah, that's the x coordinate at pi over 6. Okay. So let's practice some of these. All right. Sine of 5 pi over 3. Now, I will say, if in this video you want to have your unit circle out, you want to have your notes on these different trig functions, by all means do that. But in the next couple of days, now you really need to be weaning off of that. We shouldn't have you having to look at notes for that. You need to practice it that much. Just like 9 times 7 is 63, right? You know that number. I need you to know what the sine of 5 pi over 3 is. 5, 4, 3, 2, 1. Sine is the y value at 5 pi over 3. Remember, 5 pi over 3 is here. And this is the ordered pair of 1/2 negative root 3 over 2. And that's why that's negative. Okay. Sine of the y values. The y values are positive here in first and second quadrant, but negative here in third and fourth quadrant. Next, cosine of 5 pi over 6. 5, 4, 3, 2, 1. So I get negative root 3 over 2. How come? Because cosine is the x value on the unit circle. And when I'm thinking about the x value here at 5 pi over 6, I know that's negative root 3 over 2, comma 1/2. And since cosine is the x value, then that's what that is. Okay? How about cosine of 7 pi over 4? 5, 4, 3, 2, 1. Okay, so Cosine is the x value. The x value at 7 pi over 4 is root 2 over 2. And if you're not here yet, don't worry about it. But if you're not here in 3 or 4 more videos, yeah, you're falling behind and you really need to work on this. We'll try and do it in the videos as well. Tangent of 0. Remember, this is an angle. An angle is going in. So what's the tangent of 0? Well, I know that tangent is the y value over the x value. And what is that ordered pair at 0? Here's 0, and the ordered pair here is 1, 0. So it's going to be 0 over 1 or 0. Tangent of 0 is 0. Okay. What about tangent 7 pi over 4? Let's try that one. Remember, that's right, tangent is opposite over adjacent, or on the unit circle, y's over x's. What's the y value at 7 pi over 4? Negative root 2 over 2. What's the x value at 7 pi over 4? Positive root 2 over 2. Number divided by itself is 1, and don't lose that negative. So tangent of 7 pi over 4 is negative 1. Okay. How about cosine 5 pi over 3? 5, 4, 3. What should you be doing? You should be thinking about where this is on the unit circle, thinking about the ordered pair that you see at that place in the unit circle, and then saying, oh, cosine is the overness. Cosine is the x value on the unit circle. So I'm going to have 1 half. And think about where this angle is. Here is 5 pi over 3. And I'm looking for the x value here. This is the short leg. This is the long leg. So that's got to be positive 1 half. All right. Let's take it a step further. Oh. Can you tell me what the secant of pi over 6 would be? How about the cosecant of 4 pi over 3? Let's take a look at these. First this one. Secant of pi over 6. Oh no. Remember, that's the same as 1 over cosine of pi over 6. So if I know the cosine of pi over 6, I can just plug that in. Cosine of pi over 6 is root 3 over 2. And I'm probably going to flip and multiply, and then probably even rationalize. So I end up with 2 root 3 over 3. Ew. Yes, ew. I can also think about this as secant is the reciprocal of cosine. And if the cosine of pi over 6 is 1 half, then the secant of pi over 6 is because I'm sleeping. Okay. So secant is the reciprocal of this. So I want the reciprocal of that. I want 2 over root 3. And yes, you really do need to be in the habit of rationalizing that, because that's what you're going to see on things like the ACT and the U of A math placement test. Okay, how about cosecant 4 pi over 3? Can you do that? 5, 4, 3, 2, 1. Well, I know that cosecant and sine are reciprocals of each other. So what's the sine of 4 pi over 3? There's 4 pi over 3. And sine is that y value. Negative 1 half, negative root 3 over 2. So the sine of 4 pi over 3 is going to be negative root 3 over 2. And cosecant is the reciprocal of that. So that's going to be negative 2 over root 3. I wouldn't mark that wrong on a quiz, but really, this is pretty standard stuff that you're going to be running into. And I think that's what you're going to see on the choice, not that. All right. Fabulous. Okay. Almost done. This one. Yeah, this one. So I've got this angle, and it's not one of my normal radians. Okay, it comes down here. This is my angle, theta, and I know that there's an ordered pair here: negative 3/5, negative 4/5. Okay, and that's theta. See, theta. Well, what I would like is for you to tell me what the sine of theta is, and the cosine of theta, and the tangent of theta, and the cosecant of theta, and the secant of theta, and the cotangent of theta. What these all are for this angle. Well, remember, if we're on the unit circle, and we are, we could know that, by the way, by plugging these into the Pythagorean theorem. We'll end up with 1. So we're on the unit circle, and on the unit circle, I know that sine is the y value, and so that's negative 4 over 5, because that's the y value there. Whereas on the unit circle, I know cosine is the x value, and so there's my cosine, minus 3 over 5. Tangent is y's over x's. Negative 4/5 divided by negative 3/5, and then I flip and multiply. And the 5's cancel, and the negatives cancel, and I get 4/3. Now these 3 are just reciprocals of these 3. If tangent is 4/3, then cotangent is 3/4. If cosine is negative 3 over 5, secant, which is the reciprocal, should be negative 5 over 3. And finally, cosecant is the reciprocal of sine, and so I want the reciprocal of that, and that's going to be negative 5 over 4. Okay, so I think you should be able to do this. We will definitely practice more of that. So worry about that. Even in odd functions, yeah, not really sure. Let's go there with you. Remember, an even function has y-axis symmetry, and an odd function has origin symmetry. And the thing is, when I think about an even function, some students find it very hard to make that determination based on looking at the unit circle. Yeah. And there's an algebraic approach to this. We discussed it briefly in the fall. We said, okay, the test for an even function is that if you plug in the opposite of what you're plugging in on the original function, it should be the same as when you plug that x, that original x, not that negative x, into that original function. What does that mean? Well, take this f of x squared. Okay, and so we've got f of x, but what's f of negative x? So that's going to be negative x squared, which is negative x times negative x, that's positive x squared. Look, f of negative x has the same output as f of x. And so we know that y equals x squared is an even function. Well, in trig land, we're not going to learn the trig graphs until after we do the trig basics unit. And so you don't have that sort of graphical sense to think about, oh, does this thing reflect across the y-axis or not? And so rather than dig into that sort of old school algebraic approach for this that really no one's going to use, I'm just going to tell you that the even trig functions are cosine and secant, its reciprocal. And then the odd ones are sine, cosecant, tangent, cotangent. And how am I going to use that? Yeah, well, I really don't plan on using that a lot. But I have seen discussion of even and oddness on the ACT. And so, wow, we should probably be ready for that. We'll talk more about this evenness and oddness when we get into the graphing unit. Though, there are some practice problems that we could kind of look at now without a graph. So suppose they tell me that the cosine of t is negative 3 over 5. Okay? They've given me cosine of t. And then they ask me, what's the sine of t? What's the secant of t? What's the sine, what's the cosine of negative t? Even the secant of negative t. So how am I supposed to know these things? Okay, so what I'm thinking about here is, so three magic secrets of Trig. They're pretty easy and straightforward. The first magic secret of Trig is know your unit circle values and trig functions. This class is going to be just something that makes you cry all the time if you don't know your unit circle values and you don't know that sine is opposite over hypotenuse, or on the unit circle, the y value. But if you do know those things, it should be pretty straightforward, almost easy class. So, second magic secret of trigonometry is draw a triangle. And what I'll say is this triangle is always going to be a right triangle in the Trig Basics unit. When we get to later trig units, because I think we have 4 or 5 of them to go through, yeah, it doesn't have to be a right triangle anymore. But draw a triangle. Okay, so let's draw this triangle where the cosine of t is, where the cosine of t is negative 3 and 5. Remember, cosine is adjacent over hypotenuse. So there's my t, and I guess that's t. And now how do I find the side? Right, because I'm looking for the sine, so I need opposite over hypotenuse. How can I figure this out? Well, this is a right triangle. And because this is a right triangle, I should be able to do the Pythagorean theorem. So I've got 9 plus, I don't know, is 25. If I subtract 9 from both sides, I get 16. I take the square root, and I get the question mark is 4. Okay, so 4. Alright, so this is 4/5. Secant is just the reciprocal of cosine, negative 5/3. Cosine of negative t. What? Well, remember, cosine is an even function. And that means that whether I plug in a positive or a negative, I get the same value. So, plugging in a positive t, look at this. But we're talking about cosine. These are the ones that represent cosine as an even function. When I plug in the opposite angles, I get the same adjacent. Secant is just the reciprocal of that. Yeah? So, how about this? You do this. And the third magic secret to trig, that one's going to come up more later, and it's know and use your identities. So, What if we say that the sine of t equals 4 over 5? Okay. Will you tell me what the cosecant of t is? Will you tell me what the sine of negative t is? Will you tell me what the sine of pi minus t, and will you tell me the sine of pi plus t? That's a bunch of stuff to know. Okay, so what's the relationship between cosecant and sine? They're reciprocals, so this is 5 over 4. You know, you could also try to draw a triangle approach. This is 4/5, this is 1, this is 3/5. And there's t. And sine is opposite over hypotenuse. Opposite over hypotenuse. And so how did I find this one here? I used the Pythagorean theorem. I did 1 equals 1 squared plus adjacent squared. And so 25 over 25 over 16 over 25 plus x squared, which gives me 9 over 25. And if we take the square root of both sides, we get that x equals 3/5. There we go. Okay? All right. So these I know are reciprocals. Now what about this? Sine of negative t. And sine was an odd function. And what I know about the test for oddness is that f of negative x is negative f of x. So f of x is 4/5. Negative f of negative x is going to be minus times f of x. So we have minus 4/5. All right. Now, these sine of pi minus t. What was pi minus t? We talked about it in the last video. No, really. Remember, supplement is pi minus theta. T and theta, they just mean the angle. So I want to know about the sine of the supplement to t. Okay, so here's t, and the supplement. Well, I could draw the supplement that way, right? Because t and its supplement should add up to pi radians or 180 degrees. Okay, and what do you notice? Here, let's do some practice. This will help in 2 ways. Hey, what's the sine of pi over 6? 5, 4, 3, 2, 1. And we get 1/2. Okay, what's the sine of 5 pi over 6? 5, 4, 3, 2, 1. Well, sine is the y value. The y value at 5 pi over 6 is also 1/2. Now, these angles are supplements. Remember, supplementary angles add up to pi. Okay, so pi over 6 plus 5 pi over 6 would be 6 pi over 6, or pi. And what do we notice about the sines of supplements? Sines of supplements are the same. Okay, so this is the supplement of t. And the sines of supplements, they're the same. So this should be 4/5. Now, this is not supplement, nor is this complement. This is something a little different. Let's say I'm lying in a circle, and I'm over here at pi over 4. And that's my t. Okay, and then I want to add pi to that. I don't know. There we go. adding, oops, very away. I added pi. And now I want to know, where am I? Well, so if the ordered pair here for sine was 4/5 for that y value, over here, I'm going to have negative 4/5. What do I know? I know that this adding pi means take whatever angle I have and go halfway around the answer. So if I have instead, if I have cosine of pi plus t equals negative 5 over 13. No, we want, yeah, negative 5 over 13. Okay, so there's cosine, we've got negative 5, we've got 13. Oh, no, I don't have that. This is 12 over 13, and this is 13 over 13. Oh, okay, so here I am, and if I really want to consider this, then I have to add pi to this angle. Well, here's my angle. I guess I can see it this way as well. Here's my angle, and I'm going to add pi to it. There I am. Adding pi just goes halfway around the circle. And so now I know that this has become this, positive 4 over 13. 4 over 13? Why 4 over 13? Okay. So all this is saying go halfway around. I'm going to go halfway around the unit circle. I am here. I add half the unit circle. Now I'm here, and I see that that will be positive. Okay. Yeah, I think we'll leave it there for now. But I definitely think you should be ready for secant of 2 pi over 3, 5, 4, 3, 2, 1. No, really, we need to do that fast. What's the cosine of 2 pi over 3? Well, cosine is the x value, and the x value of 2 pi over 3 is negative 1. Secant is the reciprocal of cosine, so negative 2 over 1. Okay? Yeah, be comfortable with those. Oh my goodness, there's so much you need to be comfortable with. Yes, there is. But I think you can do it. So don't worry about it. Just practice, practice, practice. All right. Ooh, shall we have our first unit circle quiz tomorrow?